Assalamualaikum warahmatullahi wabarakatuh. Let us begin by reciting Surah Al-Fatihah. Bismillah. Greetings and warm welcome everyone to the Partnership for Innovation in Employability, PI, Research Talks towards STEM Empowerment and Sustainability, jointly organized by Faculty of Computer Science and Information Technology, led by the Dean, Professor Dr. Lu Chu Kiong and his management team. Universiti Malaya STEM Center, led by the head, IR Dr. Mas Sahidayana Mohta, and Universiti Malaya Institute of Advanced Studies, represented today by the Deputy Dean, Associate Professor Dr. Siti Hafizah Abdul Hamid. We are grateful and delighted to be sharing this wonderful stage with several dignitaries from UM. We have Professor Dr. Siti Nurshina Muhammad Zain, Director, International Relations Office, Universiti Malaya. I believe we are expecting, but we are not here yet, Associate Professor Dr. Lai Sai Hin, Deputy Dean of Research, Faculty of Engineering, UM, and Madam Vigneshri King, Director, Global Enrichment and Mobility, GEM Center. So, Partnership for Innovation and Employability, PI, is a program for women in STEM. It's actually born from a concerning gap among universities in the UK, Asia, and Malaysia that we do not have a formal research and mobility collaboration for learning and teaching and employability initiatives. Therefore, several mind-like academicians from the UK, Indonesia, and Malaysia forwarded an international grant application to the 2021 British Council call for catalyst grants for enhancing graduate employability with the hope to foster the first partnership of a long-term self-sustained collaboration for women in STEM research, learning and teaching enhancement, as well as employability empowerment. Allow me to extend a warm welcome to the PI members. Joining us today is Dr. Yixin Chiu, Director and Founder of the Eureka Robotics Center from Cardiff Metropolitan University, England, Dr. Barry Bentley, Deputy Director of the Eureka Robotics Center, Dr. Charles Xingxia, Co-Head of the Eureka Robotics Center and Lead of the STEAM Lab. We also have lovely interns and research students from Eureka Robotics Center. We have David, Jack, Avin, Siad, Kehinde, Howlin, Jinyu, Debika, and Caroline Pratt. Not here with us today, one of our UK partner is Dr. Peng Cheng Liu from University of York. He'll probably join us next year, Mr. Mifan. All right. So we also have PI Asian partner from Indonesia, Dr. Devi Fitriana. She's a lecturer specialist from Universitas Bina Nusantara, Indonesia. We have PI Malaysian partners, Dr. Associate Professor Dr. Rosita Chailani from UITM. We have Dr. Anwar Majid from UC Malaysia Pahang, and myself is one of the collaborators. I'm Sati from UM. We hope to connect with Malaysian industry partners, and I'm so happy that they have graced this event today. We have Ms. Lee Pei Pei, Director of Nurse from Alti Hospital. We also have Dr. Jeffrey Tan, Technical Director of Latel Sdn Bhd, who focuses on AI robotic solution. To officially begin the program today, please join me in welcoming Professor Dr. Lu Chu Kiong, Dean of Faculty of Computer Science and Information Technology, Universiti Malaya, to give his welcoming remarks. Please welcome.
Okay, very good morning. First of all, I'd like to thank Dr. Zati, our MC for today's event, and the working member of the Partnership for Innovation in Employability PIE program for women in STEM. So it is my pleasure to welcome all of you to this PIE research talk, in which I believe will bring forth great opportunities to kickstart a global partnership in research and graduate employability as part of the British Council's UK-Malaysia University Consortium, UK-MUC, led by Dr. Ishin Chew of Cardiff Metropolitan University, CMU. I congratulate you and your team for receiving £50,000 to kickstart this wonderful international partnership and launch as a serious conversation on the long-term self-sustainable collaboration for women in STEM research, learning and teaching enhancement, as well as the employability empowerment. It is my pleasure to convey that FSKTM and UM is 100% support with this great effort, and I'm proud that we have Dr. Zati, who leads AI robotics teaching and research, to represent us. Dr. Zati also brought to my attention that apart from knowledge sharing and research networking, an opportunity for STEM upskills and enhancing graduate employability. The PIE program is also seriously looking at research, particularly in finding opportunity in dual PhD supervision opportunities in STEM-related areas, international grant application opportunities, and international linkage and MOAs. I feel our vision in terms of research is definitely aligned, and I would love to hear more about how can we explore this research opportunity together in future. Thank you very much.
Thank you very much, Professor Lu. I would like to continue with our first agenda of the day, talk number 1. Please welcome Dr. Ishin Chew from Eureka Center.
Hello. A very good morning to everyone. Hi, my name is Ishin. I actually used to work here and study here 20 years ago. And Dr. Hanafi, I still remember the first car that I drove, Kalisa. She just reminded me. So I feel a bit emotional when I come back to, like, as an alumni, as a co-worker in Universiti Malaya. So a warm welcome as an anak Malaysia who work in Cardiff. So I represent Cardiff Metropolitan Universities, which won the University of the Year 2021, just recently by the Times Educations in the UK. And I'm proud to represent Eureka Robotics Center to share with you the experience of our research center, as well as how this global service social robotics can come all together. And that's my team. If you can see the slide coming up. So if you can see a quick photo that we have the end of term party usually. So just want to share.
I think it's there's a lot of things on.
Okay. Oh, you do YouTube live?
Yes.
So I have to keep talking then.
Probably we can just start with,
Sure. Now, 2 years ago, I was here bringing 10 students for the similar mobilities. And that time I met Professor Lu. And her magic robot was impressive and it's inspiring. During COVID time, we couldn't make it, although we got the grants to come again, but we couldn't make it, but it's fine. So today, I just won the 50K British pounds pie for women. It's always my passion to engage ladies in STEM, from nursery way up to higher educations. I can see some young minds here who study computer science in this faculty. I hope that the coming few days, you can have very good communications, knowledge exchange with our PhD master interns here. So globalizations, mobilities, that will help a lot. Okay, we are here funded by UK government's Turing scheme, so that the UK government encourage all educationists, students, staff to go abroad for globalizations, knowledge exchange, etc. So if for people who don't know where we came from, so that's Cardiff, about 2.5 hours from London. So we flew all the way about 13 hours to here. The center that I founded, and I'm the director of the centers now, is called Eureka Robotics Center. Just a quick question. Do you know what Eureka means? Anyone? Yeah, of course. Success. And? Anyone else? It's a term. I like you. What is your name? Rai. It's brilliant. Yeah, Eureka means exclamation, engaging, finding solutions, solving a problem with fun and engaging experience. So that's what it means. The first time I came to this word was in 2016 when I visited Melbourne. And that is a Eureka Tower. So if you have been to Melbourne, I recommend you to visit that tower. And in that tower, there is the Edge experience. So the Edge, it's exciting. And there's the highest box. So Eureka Tower is the tallest building in the South Hemisphere. And when I joined Cardiff Met had this exactly same motto called the Edge, Cardiff Met's Edge, Ethical, Digital, Global, and Entrepreneurial Skills. So I quickly linked that together, and I used that name, and I founded Eureka Robotics Centers in 2018. After 2 years, we are privileged to be profiled by the UK government. It's one of the 11 labs at that time. We were granted center status last year. So at that time was Eureka Robotics Labs. And we are one of the 11 lab or center in the UK specializing in service and social robots. Other center, for example, Imperial College, they are quite good in skeleton robotics. Oxford Robotics Institute, we visited there 2 months ago. They were specializing in mobile robotics, autonomous car, and etc. So that's us. We have more than 60 robots, mainly humanoids. 2 research labs, few printers, machines, gadgets. Just now Prof. Lu asked me, what is this? This is Robot Nightingale, one of our flagships, robots much better than Pepper. These are cooking robots, and a few more. We brought this today, this one, and it will be handed over, shared by UiTM and UM for our collaborations. More importantly, it's not just the robots. I have very strong teams. We have more than 20 researchers, graduated 25 interns in the center. And we have end of party almost every year, except during COVID. We work closely together. We also publish profile by the UK government as one of the long-term care R&D across the UK. Started off with rehabs, specialist play robots, and now to service healthcare robotics. My student programs, we don't actually build robots. We 3D printed robots, some of the parts of the robots, but we program robots. These are some of the pictures that you can see. For those who understand or familiarize yourself with knowledge transfer, KTN in the UK context. So KTN also profile us as one of the UK's growing robotics AI sector. And you can see this is the capabilities and technologies that they profile us with 4 labs there. And we are the only one as a universities to be profiled. The rest are mainly companies. So it means we transfer knowledge from universities to companies, to hospitals, to care home, to public, to schools. That's what we do. So as a nutshell, we have 4 labs now, started from STEAM Lab 2018, healthcare, IR Miracle Lab with the 3D printings, robotic parts, autonomous labs, and then Bell AI Lab this year. led by Dr. Barry. You can see some figures there. We approach many students, teachers, etc. And we are very interdisciplinary. We encourage interdisciplinary research. Therefore, we have global partnerships with different companies. We just signed an MOU with Bellcare UV. It's the only company in the UK that manufactures far UV disinfection robots. The disinfection robots that you see in the world now, in the market now, is just UV disinfection. So when you do the disinfections, you have to evacuate the rooms. But far UV means causing no harm to the skin. So we are under R&D now with that company to integrate our robots with their far UV into a new inventions and bring the cost down about 80%. It's under R&D. We emphasize in robotics ethics because we have a vision to bring robots to the real world. So ethics is very important. Very important. We draw the first Toku zone in Wales and Malaysia where robots and humans coexist. So that's Toku zones, and we have lots of different expertise. You can name it. These are our partners. You can see different university names. KAIS is the Korean technology, and we are now in UMP is there, UITM, and etc. And a few robotics companies in London and Malaysia. That is our strategic partners. Just give you a quick photos, recap what we have done last 2 weeks. This is in UITM. UITM brought us to a girls' school, approaching 2,000 students. This is UMP. We were there last Wednesday. Thank you, Anwar. We met Prof. Nurul. She's also an advocate for STEM. Is their Pro-Vice Chancellor Assistant for Global Engagement. We visited their labs. It was quite nice. Autonomous bus they developed. We met the deans of engineering and the FED as well. We were in Alti the first week. So thank you to Ms. Lee. She's here today. We are deploying 2 service robots in that hospital in Jalan Ampang as the first hospital in Malaysia who will pilot service social robots for nursing care. So our staff talk to their staff, understand, explore the challenges of nurses working in the real world and how AI can help them. Just give you a quick screenshot. So this nurse, within half an hour, she learned how to control a robot into the ward and just play around with it. Last month, we trained Cardiff and Vale Health Board, equivalent to UH here. It's a university hospital in Wales. We train their physiotherapists, their assistant nurse, not even a qualified nurse. Within 2 hours, Arvin taught them how to control a disinfection robot, how to use disinfection robot, how to integrate it socially, ethically in a hospital environment. And they tweeted, we are having a joint press now. So it's a very fruitful collaboration with them. I just want to show you this video. Yeah. I think she's almost reaching a retired age, that nurse. But she can quickly be trained and pick up how to manage, control a robot for disinfections, which is usually her work to do some disinfections before and after the consultancy or before and after the operation. So we really amazed and think that with the integration of robots, yes, jobs can be taken over, but people can be upskilled. Even a retiring age nurse can do. I believe many of us can do the same thing. And she didn't, she enjoyed robots a lot. We also deployed the same robot and a few more robots in the care home in Wales. This is during the Christmas time, during the lockdown time. So the robot sang carols, to the residents, to the elderly people, and the families and friends can teleconference their parents in the care home where they couldn't physically visit them. So that make a huge difference. It's not just a Zoom, not just Teams, but they can actually remote control the robot to the ward and talk to the family and friends that they miss, that they love. So there's another kind of social impact. The residents loved them. They tweeted him. When we took that time was just a loan, a free of charge loan. When we took that robot back, they had a farewell party to him. So they can actually establish that kind of social bonding with a robot. So if you would like to learn more about our research in terms of the academics, so we have published some papers there. Feel free to go to our website and learn further. I also published in UK Parliament, AI Select Committee, a few years ago, about the visions, about the work on how we embed social humanoid robots into the real world. And at that time, UK can lead the way in ethical AI. Is it able? Is it willing? Is it ready? That's the research questions we need to ask and we need to resolve. I think Malaysia is more accepting. You can see more robots in restaurants, especially this time when I came back. 3 years ago, I only see 1 or 2 robots, that's all. But this time, almost many restaurants, they embed the low-cost, the low-intelligent robots. I believe in 5 years' time, Malaysia can see more intelligent robots like this, not just the low-end one. So it's more accepting. And I believe Dr. Zati, Prof. Lu, can lead the research innovations and give impact to the UK. That's what we do in Wales. And that's my another project, research that received funded by Welsh government, nearly 1.8 million. We integrate 12 robots to 2 hospitals and 1 care home. Customize some apps with my students' research, embedded it. So they just not publishing on papers, but they also try to embed their research into the robots and to the real world. And we also profiled by the UK government in the 4th Industrializations Revolutions publications about the work that we do in the UK. Excitingly, SEA Games launch in next month. We are invited to send our educational robot, led by Dr. Barry and Sia. I'm still here in Malaysia, but they will go there to meet different ministers, VIPs, as a closed-door meeting from the Commonwealth country to help to create a visual, innovative impact on the day, as well as furthermore collaborations for the Commonwealth countries to probably adapt our robots. Reskilling, upskilling for employability is the main theme for Pi for Women. I do not know what's the SKTM ratio now, but I can see from here, mainly boys, a bit of girls here. It's always my passion to encourage girls from primary school way up to undergraduates to take up STEM subjects, especially robotics. If you attend robotics conference, mainly guys. I think only Zati, yeah? So we need some educational enhanced program with with Dr. Hanafia in the futures to prepare them, to prepare girls for STEM. And thus, in Eureka, we have internship leadership programs. We're looking good care of my interns, so we don't develop them as an IT geek. But we are engaging. Boys and girls, we bring them out for a festival, to Thailand Museum, to Cardiff Museums, showcase their work. We have parties. Our robot even flew to the South Pole with famous athletes for well-being analytics, emotion analytics. And I collaborated with Human Rights Malaysia a few years ago to do child right using robots educational program. We run yearly competition before COVID, and I hope to extend that to UiTM and UM. We can have a global kids competitions for robotics and AI in the future. So that their jobs will not be replaced in 10 years' time. Ladies and gentlemen, if you are interested to join us for this Pi for Women project, feel free to scan this QR code. We will have more mobilities activities coming in. Either we bring you to us, to Cardiff, or we come to you. So that is the whole purpose, beautifulness of mobility, of knowledge exchange, of connections, of engagement like this now. I can see you face to face, eyes to eyes, not to Teams or Zoom. I really enjoy that. By that, I would love to announce, on behalf of Eureka Robotics Centers, funded by British Councils, we are bringing in this robot, Robot Eureka, we brand it. Model is Sandbot Elf to FSKTM, to Dr. Sati, and to be shared with Dr. Rosiati in UITM, and we're placed permanently in Malaysia for our collaborations, for our students, app development for AI research together. So this robot, exactly the same model, placed in Italy Hospital during the COVID time for telemedicine, for conferencing. So thank you once again, Prof. Lu and colleagues, to host us.
Thank you, Ishin. Thank you, Ishin, for the introduction and comprehensive overview of what Pi for Women is about and what our role is in encouraging STEM. I think you have a gift to UM. So we would like to invite Prof. Lu Chiu Kiong to probably receive the robot presented to us. Yes.
Can I ask Jack just to make the robot dance?
Okay, Jack, come over. So I'm so excited and delightful to share that this robot will be coming to my lab and for my students. So you'll be enjoying this robot in the next few months. And Ishin, I would like to say that this year, my students' final year project, AI robotics, I have 9 students doing robotic project this semester. 6 of them is women. So for this first time ever, I have ladies more than the guys. Yes, I'm catching up. Okay, so thank you so much for the present. This is to symbolize our collaboration. I would also like to invite to the floor for a quick photo session because we're going to coffee break after this. So maybe Prof. Nushina, please come to the stage. Dr. Barry, Dr. Mas, Dr. Siti Hafizah. Oh yes, sorry. Quick, give me a moment because the robot will be dancing for us before that.
This song list chosen by Miss Lee's staff, nurses, working in a very stressful time. So they uploaded lots of songs that are favorites by nurses. Which one you choose? Oh, this one. This is my favorite.
Is it a classical?
Take a guess.
Oh.
You know? Yeah. When it comes to UK, I can bring you for the...
So apparently Prof. Lu likes classical music. So classical music to Prof. Lu is release stress.
The name is called Phantom of the Opera.
You can see it. You can see it.
Sati want me to say the name. It's Phantom of the Opera.
Okay. So yeah, please, Prof. Lu, for a quick photo, please remain on the stage and please welcome Prof. Siti Noshina and our delegates. Yeah, Dr. Siti Hafizah, Dr. Mas, come over to the stage. Madam Vicky, please, we need you up here. Do we have Associate Professor Dr. Lai Saihin? Yes, please. I was looking for you. Please. Please. And Associate Professor Dr. Rosita Anwar, would you like to join? Okay, so this is a gift to you, and I'll make use of it properly. Thank you. We will adjourn for coffee break. Coffee and tea served outside. Please welcome yourself. We also like to invite Madam Vicky, Professor Siti Noshina, Professor Dr. Lai Sai Hin, Dr. Ishin. Prof. Lu, would you like to join us for a quick introduction? And Dr. Barry, yeah. So we'll adjourn for coffee break, and the names that I mentioned just now can follow me to the meeting room. Come. Pukul berapa? Sekarang ni dah pukul 11. 11 pukul 10, 11.30. Tak ada orang nak setengah jam. Discussion tak apalah. Kita start 11.30. So please join us again here at 11:30 after your coffee break. Thank you. Hi. Hi, Sophie. Thank you for coming. Okay.
Blank tak ada dia. Tak ada ni, tak ada blank. Dah. Kenapa dia tak boleh blank kan? Pelik aku lah.
Tak boleh blank slip, tak boleh.
Tak ada kan? Projector lain.
Freeze.
Freeze tak lain. Sekejap.
Tak jalan.
Dia blank ni digelap.
Dah boleh kemas, jom. Kemas.
Tahan sikit. Siapa? Wani. Wani digi je sini. Nak cover ni. Cover yang mana? Belakang tu? Cover ni. Situ okey tadi. all for coming back to this hall. We're going to resume our talk. So if you're feeling a little bit hot, because we were opening the doors just now, so the aircon will come back up a little bit. Right, so I would like to introduce our second speaker of the day, talk number 2, investigating fundamental biological principles to inspire the design of next generation AI and robotic system. Please welcome Dr. Barry Bentley.
Okay, good morning, everyone. So this is my first time in Malaysia, and it's an honor to be here today, so thank you for inviting me. So my name is Barry Bentley, and this talk is going to be slightly different. This is going to be about my journey in AI, robotics, and biosciences. So I thought I'd start with some information about myself. As has been said, I'm the Deputy Director of the Eureka Robotics Centre at Cardiff Met, and I'm also a Senior Lecturer in Computer Science there. But I thought I'd put some information up on my educational background to give you some idea of where I come from. So I originally did my undergraduate degree in Computer Science at Plymouth. I then did a PhD in Neuroscience at Cambridge, and then I did a postgraduate certificate in History at Oxford. So that's my background, and today I'm going to talk about my own personal journey in research. So I'll talk about some of the projects that I've been involved in related to AI and robotics, and towards the end, I'll share some things with you that I've learned during my career so far that you might find useful. So I thought I'd start at the very beginning, and when I was writing this, I was trying to think about where my interest in AI and robotics originated. And one thing that I kept coming back to was an early inspiration for me, which was the TV show, Star Trek. So for those who know the show, Star Trek presents this vision of the future where humans use technology and work together to explore the universe and try to solve problems. And that really inspired me as a child. And that's what sparked my interest in studying science and engineering. So I knew early on that I wanted to be a scientist. And in particular, this character, Data. So Data was an advanced android, a humanoid robot on the TV show. And he presented this vision of what AI would be capable of in the future. So this inspired me to want to study AI, computing, science and engineering. And so I started teaching myself how to program. And so the very first programs that I started writing were the same types that most people start writing, simple rule-based programs to get the computer to respond. And so I built up these chat programs, and I remember wanting to bring the system to life. And this is what inspired me to go on to study AI and computer science at university. And underpinning all of that was this motivation of wanting to understand intelligence. So I went to university, I studied AI and computer science, and I wanted to find the best labs in AI and robotics in the UK. So I looked, and at the time, there was one professor, Professor Angelo Cangelosi, who had received a lot of media coverage for work that he'd done on unsupervised language learning in robots. So I reached out to Professor Cangelosi, and I asked to join his lab, and that's really my first experience of research and how I got started. And I was very fortunate to join the lab just as it started work on the iCub project. So iCub, some of you might know this robot, it was designed based on the body form of a 3-year-old, and it was modeled or based on this idea of embodied cognition. So we know that infants learn by interacting with their environment and interacting with other people. So by embodying the AI in this childlike body, we could study the processes involved and how humans interact with robots, how humans interact with children, and how they teach them. So this was my first experience in research. I was involved in setting up, supporting, maintaining the iCub robot. And I'll just show a short video of one of the experiments. There we go. So this is the iCub robot. This person here, this is Dr. Anthony Morse. He was a researcher in the lab, and he was developing neural networks that could do online learning for language. So here we're teaching iCub objects. So it's got an attention mechanism that orients towards highly salient objects in the environment. And then we're just teaching the robot names of different things and asking him to follow them. So this was heavily inspired by ideas from psychology and biology, and we're trying to implement those in neural networks to make the robot intelligent. So as I said, that was my first experience in the lab, and you can see here a photo of the lab. There's iCub in the middle. And that led on to a second project. So the second project that I was involved in was working on Mars rovers for the European Space Agency. And this was slightly unexpected at the time. So there was a researcher in the lab, Dr. Martin Penyak, and he'd presented some work at the European Space Agency talking about evolutionary robotics. And that interested them at ESA, and so they invited us to work together on a project looking at different types of control systems that could be used for Mars rovers. And so I'll just give you a quick overview of some of that work that I was involved in. Okay, so to give some background, as I'm sure all of you know, Mars is an extremely long way away from the Earth. And just to put that into perspective, to send a radio signal from Earth to Mars and then receive a reply takes about 42 minutes. And so that means that there's absolutely no way that you can control a robot on Mars in real time, remotely. So any robots on Mars have to be able to navigate and behave completely autonomously in a safe and reliable manner. So this is the main thing that we're interested in with Mars rovers. How do we get them to behave fully autonomously in a reliable way? The traditional approach is to use 3D imaging. So we have a pair of stereo cameras. They take the parallax between those images to create a map of the environment, and then it can navigate based on that. So this is very effective, but it's extremely computationally expensive to do all this processing on low-power hardware in space. So we have very little power that we can utilize on these rovers. And to give you some idea of just how slow this is, the previous generation of Mars rovers, the MER rovers, traveled slower than 1 centimeter per second because of the computational load involved in having to do this processing. So we wanted to see whether we could take ideas from biology to create more efficient control systems for these rovers. So that's what we were looking to do, create low-power systems. So we got to go to the European Space Agency Technology and Research Center in the Netherlands. There's some photos here. So this is where they design and test much of the space hardware. And it's also where they have the rover test environment. So they have a simulated Martian environment. So we got to go to this and see the test rover that they run the algorithms on. So they develop new algorithms to trial and then test them in a simulated environment. And what we wanted to see, as I said, was whether we could use ideas from biology to increase the efficiency of these rovers. And what we initially looked at was evolutionary robotics. So evolutionary robotics, I won't go into too much detail, but we used the idea of replication and selection. Okay, so we start with just a random population of controllers. So each one of these rovers is completely randomized, and then we put them in the environment, test them, select the best, test it again, and then keep iterating this. And eventually, after hundreds of generations, you end up with a rover or a robot that can operate based on whatever criteria you defined in the beginning. Yeah, as I said, I won't go into detail, but we looked at how we could speed this up, because this evolutionary process takes a long time, and we found that we could parallelize it by splitting up the populations. And as a result of that, we're able to increase the efficiency. Of course, because, as I said, this takes hundreds or thousands of generations, we couldn't do this in the actual rovers, so we created a simulation to assist us. There's just some images. And what we found was that we were able to increase the efficiency and decrease the time it takes to evolve these controllers for the Mars rovers. And here's just a video of one of the simulations with the rover exploring the environment. And then we looked at incorporating vision into this as well and detecting different types of terrains so it can explore and avoid potentially dangerous terrains. And there's a photo again of the team, this time at ESA with the Mars rover. So that was the first part of my career, working in robotics. And throughout all of this, I was interested in this question of what is intelligence, and can we copy those processes and instantiate them in hardware? But I soon realized that we really don't understand much about what intelligence is, how it works, and the algorithms, processes underlying intelligent behavior. So I decided to switch career paths and look at intelligence from a biological perspective. So as I said at the beginning, I wanted to better understand biological intelligence, and so I went on to do a PhD and postdoc in neuroscience at Cambridge. So this was going into the lab, doing experiments, and then doing computational work to support that. And I was chiefly concerned with this question: how do brains generate intelligent behavior? So we know that brains do generate intelligent behavior. So if we can understand how the brains do it, or how the brain does it, then we can take those processes and use them to design AI systems. Okay, so I thought I'd start by just giving some context of the sort of question that I was interested in. So if you look at the nervous system, you have this hierarchy of complexity. So at the lowest level, you have genes and molecules, and those make up cells. And then we know that those cells interact with one another in networks. And it's these interactions that produce the intelligent behavior. So I was interested in this question: how do these connections, what is it about these connections that can generate the type of behavior that we're interested in? And can we use it to create new types of AI systems? So this is what these networks look like under a microscope. So these are brain cells, neurons, and these are densely interconnected with one another. And there's a huge number of these inside the human brain. So there are about 100 billion neurons in the human brain. And to put that into perspective, so that's 10 to the 11, that's the same number of neurons as there are stars in the galaxy. So there's a vast number of cells. And the way that these cells communicate is by releasing these molecules, and they bind to receptors. So that's how these two cells transmit messages to one another. So as I said, I wanted to understand how these networks create behavior, create intelligence. And the field that's concerned with that is called connectomics. So connectomics is all about mapping and studying these networks, the connections. And the ultimate goal, obviously, is to map all of the connections, with the assumption being that if we have the wiring diagram, if we have the network, we can then understand and reverse engineer behavior. So again, I won't go into too much detail about how this is done, but we take a nervous system, we extract the connections in some way to give us our network, and then we can analyze it. And this is what I wanted to do. I wanted to understand what these connections are, what makes them special, and how do they generate behavior. So we can do that by taking microscopy images. We use machine vision to identify the cells. And then we can take those slices and reconstruct what the nervous system, what the network looks like. And it's just a video. So here we have each one of these is a different slice through a nervous system. And then we're reconstructing the network from that. Okay, so far we're a long way off from completing this network of the human brain. So as of last year, we've only completed about 1/1,000,000th in terms of the mapping. However, there is one animal, and at the moment only one, that we have the complete nervous system for, the complete connectome, and that's this tiny worm called C. elegans. So C. elegans has only 302 neurons versus the 100 billion that I mentioned in humans. And despite having a very small nervous system, it has all of these interesting behaviors. So they can feed and forage, they can find mates, and they can learn simple things, so they have memory. And that's what its network looks like. There's just a short video showing what they look like under the microscope. So these worms, as I said, have some level of intelligence, and yet they have a simple network. So the question that I wanted to understand was, how do we take that network and then understand behavior from it? And it turns out that we're a long way off from achieving that. So we've had this network since the 1980s. So it was originally mapped by hand, which was possible because it's so small. And yet we don't understand it. We don't understand how, with just 302 neurons, this tiny worm can generate all of these intelligent behaviors. So this is a problem, and this is the problem that I was concerned with for my PhD. So we have this assumption that the wiring diagram will allow us to reverse engineer behavior, but it turns out that that doesn't seem to be the case. So why? And what my research ended up leading me to was that there are different ways, different modes of communication between neurons that aren't currently being considered in the current models. And the main one that I was interested in is what we termed wireless networks. So earlier I mentioned that these neurons communicate by sending chemical signals, but we know that those chemicals, those molecules, can also diffuse over large distances. And so we have a form of wireless communication where the cells aren't connected to one another, but the molecules can still travel and send messages. And what we found was that these networks turn out to be really important for a number of things. So we used computational techniques to map these networks, and then network analysis, graph theory to analyze them. And we were able to map most of those for this worm, C. elegans. And we found some interesting things. So we found that they're mostly star networks. And this seems to match what we find in the human brain. So we know that a lot of the signaling centers where these molecules are synthesized are all in the midbrain and the brainstem. And then the receptors for them are all throughout the cortex. So it seems like this is an important principle for intelligence or generating behavior, that we have some central control center that can signal to the entire brain simultaneously. We also found that these networks provide a shortcut, and we call it the wireless shortcut. So normally, processing goes from the sensory, the input, to the interneurons, and then to the output, the motor neurons. But this wireless signaling allows a shortcut directly from sensory to motor. So this is something that's being missed in the current pictures of how brain networks function. And we found several different things about how these networks generate behavior, and feedback seemed to also be an important aspect. Again, I won't go into the details, but the idea is that there's more to the function of the nervous system than just these wide connectomes, these wide synaptic networks that were traditionally considered. So that was my move into biology. There's just a recap of my career up to that point. So I started at Plymouth, interested in robots and how we can make robots intelligent, then onto Mars rovers, and then trying to address this fundamental question of how intelligence is created at the biological level. I then went on to lecture for the Open University and did the graduate work at Oxford that I mentioned. And then recently I joined Cardiff Met. So that's the Eureka Robotics Centre. And there's a photo of our campus in Cardiff, where we're based. So that's a recap of my career. The final thing that I wanted to talk about was some of the observations that I've made during my career in research so far, and some things that I've learned that I think you might find useful, at least I've found useful in identifying. So I said I did my PhD and postdoc in Cambridge, and I was extremely fortunate to be at what's considered to be one of the best biology labs in the world. So I was at the MRC LMB, and that's had 27 Nobel laureates work there. And there were 3 there during my time at the lab. So there's Venki Ramakrishnan on the left, Greg Winter, and Richard Henderson. And so being in this lab, I had a chance to interact with these Nobel laureates, and I learned some interesting things about research and high-quality research. So what did I learn? Well, the first thing, and I think perhaps the most important thing, is that Nobel Fellows are normal people. There's nothing exceptional about Nobel laureates. In terms of their work, there obviously is, but ultimately they're just people. The second thing that I learned is that the facilities and the resources are not the most important thing. So the department that we were based in, the building, it was an old building. It was originally designed in the 1950s. The windows and the roof leaked when it rained. It was cold all of the time. There was very little room to work in. We had hardly any lab space. And there was really nothing special about the facilities. We didn't have any equipment there that you don't have at any other large university. And I was remembering before I came up today that the elevator in the building also broke down fairly regularly, and one of my lab mates got trapped overnight in it once. So it was it wasn't a great place to work. And there's some photos. So this is the main staff room. So you can see there wasn't much space. This was shared by pretty much the whole department that I was in. So going back to what I learned that Nobel Fellows are normal people. They have high standards, but really there's nothing special. There's also nothing special about the facilities or the resources that we had. But the one place where there was a big noticeable difference was in the attitude and the belief that people took to their research. So firstly, there was the expectation that everyone there was working on something important. So people weren't just working towards targets, towards meeting some publication target. They were more concerned with the scientific aspect. What problems do we need to solve? What are the important problems? Not, how many papers, how many talks do I need to give? So we're very concerned with the underlying science. The second thing that I noticed was that there was a belief that everyone there was capable of making breakthroughs. So it wasn't just the Nobel Fellows, it wasn't just the professors. There was this idea that if you were in that lab, you were there to do important work and that you could do important work. And that motivated people. And as I said, there was nothing special about that place, but there was about the attitude. And the final thing is that obviously it was a very intimidating environment to be in, but failure was acknowledged as a part of research. So we were all encouraged to try high-risk, high-reward projects. So obviously, the bigger the project that you take on, the riskier it is, and so there's a higher chance of failure. But by acknowledging that risk of failure and acknowledging it as something that's an integral part of research, that gave people the courage and the freedom to take on those projects. So I want to leave you with a closing thought. and that is that I've learned that there's nothing special about the people or the facilities that win Nobel Prizes, but there is a difference in culture. So this is a question that I try to ask myself regularly, and I think it's useful to consider as well. And that is, how can we encourage, support, and challenge one another as academics to do world-leading research? Okay, thank you.
Such a wonderful talk by Dr. Barry. Thank you so much for inspiring us. I've met Dr. Barry for about a week now, yeah, and we were in car rides to Pahang together last week. Well, I can say that he has all these portfolios behind him. He's such a humble person to talk to. So my students, please talk to him if you have a chance this afternoon. Okay, you can learn so much from him. Yeah, don't waste this opportunity. He comes from very multidisciplinary background, and he's focusing on robotics like us. So please learn from him today. I would like to invite the next speaker, Dr. Sia Chow Sing, to the stage. Very useful. So Dr. Sia will be talking about her work at the Eureka STEAM Lab with, I think you're also going to talk about the certifications? Yes, okay, so please welcome.
Hi, good morning, everyone. My name is Sia. Just call me Sia. That will be fine. Thank you for the organizer that I'm able to be here to speak to all of you today. It's actually a great opportunity for me to be here to meet some of you. Unfortunately, I haven't have an opportunity to talk to all of you, but hopefully that during the lunch time. So please, if you are interested in my work, please come and approach me, okay? So, so as mentioned, I'm actually the co-head for Eureka Robotics Center, and I'm actually the lead for STEAM Lab. So we call them STEAM rather than STEM because we do have A in between. A stands for artistics, okay? So, as mentioned by Dr. Ishin before, we do have more than 60 robots, human-made robots in our labs. We use them for multi-purpose, healthcare, and obviously educations as well. We do have a beautiful teams and a very amazing teams, which is some of them are actually sitting with us today. So I was actually greatly supported by Arvin, Shu Yang, and Jack, which is probably at the other door. So we actually have been having quite a great fun together. So part of our jobs, obviously, is to provide talks or robotic sessions to either the schools. So the schools that we are actually going for is primary or secondary school. And again, of course, either we go there or they will come to our university to visit us, and then where we will conduct some workshops with them. So this workshop actually contains of topics about, let's say, programming, learning programming languages, and we will also do some robotics demonstrations with them as well. Okay, so my work is slightly different because Dr. Barry is looking at very, very intelligent area of research, and Dr. Ishin is looking at more towards services, humanoids, robots, serving hospitals as well as healthcare. Mine is actually more towards education. So I speak to little children, okay? So I'm just going to show you a video of the work that we have been working on so far, and you will be looking at, I don't want to spoil too much about the video, so I'd like you to enjoy the video first, then we come back to about it. Okay, so this is actually, so you can, from the video, you can see how enthusiastic the children are when they actually engage with robots. So you'll be very surprised. It's actually a very rewarding experience. I think Arvin actually has the most rewarding experience when she actually conducted the workshops with these children and how they react. They are really having a very sort of happy emotions, and they are actually accepting robots as sort of a big toy with them. So this is a part of our STEAM lab purpose, is to help the children to understand about how the robots can interact with humans, and you can see how happy they are when they actually look at them and they actually respond and react and even sing and dance with them. So I'm just going to show you another video clips as well, just a very quick overview about a fest that we have in one of the college in Wales. And again, of course, you can see the expressions of the kids. So please pay attention to the expression of the kids when they actually look at the robot. Hang on, not this slide. Okay. Okay, so I just replay this. Okay, thank you. So that's the end of my video presentation, but that's not the end of my talks. So again, of course, there's a quick one. Sorry, I just need to skip some of the slides. So this is actually being quoted from Dr. Ishin's articles to the UK Parliament, and from the article, it is suggested that the educational programs or curriculum need to be reflected from preschool right up to higher education. So that's our motto for our STEAM lab as well, where we introduce robots to young children, and hopefully they will sort of, we put on a seed in their mind, hopefully, and that that will inspire them to do some computer science or even some robotics engineering later in the future. So another part of the STEAM lab, obviously, is we are hoping to achieve what we know as Eureka certifications as well, where we are going to provide some workshops to the teachers, where we again provide trainings for them, and that they are being trained to use, let's say, some of the robots and obviously some programming concept as well. For the past few months, since the UK government has been releasing their restrictions, we actually received quite a number of invitations from not only from the schools, as also from the school teachers who would like to be involving in our STEAM workshops. So we are hoping that moving forward, we will be able to provide more standardized and professional workshop to this school. And in actual fact, Dr. Ishin has started this particular idea and projects before COVID, but because of COVID, then we stopped for 2 years. So we are hoping to carry on with that particular effort. Okay, so that will be the end of my talks today. So if you are interested to know more about it, so please let me know. Okay, thank you.
Thank you so much, Sia. Lovely presentation, something that we have to work on it today. Because in Malaysia, we don't have such certification program for robotic. We do have, I think for school level, Arduino, Raspberry Pi, those are common. But AI robotics, something a bit more serious that really impacts employability, is something we don't have yet formally. So we'd love to learn from Sia and your team. Thank you. I would like to invite a special guest. It's not mentioned in the itinerary, but a special guest, Caroline Platt from Eureka Center. Allow me to introduce her. She's formerly with Ministry of Defence in Wales, and she is a role model to all of us because she is STEM for women. Come forward, Caroline.
Thank you. Good afternoon, ladies and gentlemen. My name is Caroline Platts, and I'm a recent member of the Eureka Robotics Centre. As Dr. Chu said, we've travelled from Cardiff, which is down at the bottom of the UK. And again, in the large-scale map, you can see that we're a very long way from Petaling Jaya. We've travelled a long way, but we're delighted to be here, and thank you very much for inviting us. I thought perhaps I would just show you some slides of what the UK looks like. I don't know if anyone has been there. We have a lot of hills, valleys, dry stone walls, stone buildings. Other parts look like this, houses down in the valleys. It's quite green, a bit like Malaysia. Or here we have a city view, and you probably know that's London, and that's out at Greenwich. You heard from Dr. Barry that we won the University of the Year 2021 from the Times Higher Education Awards. We're really proud of that. And again, I think you saw the slide earlier that this is our campus. Up in the top left corner, that's the sea, the Bristol Channel, and the river there. That's my commute in the morning. I have a riverside walk and walk home at night. It's very nice. My story then, I was born in Scotland, which is at the north of the UK. And my first job, I had the Queen's Commission. I was an officer in the Royal Air Force. My job during that time, I did some air traffic control, not very successfully, and I changed to work organising royal and VIP visits to the main Royal Air Force Base. The visits were for diplomatic reasons, UK Foreign Office, or VIP visits. For example, Her Majesty the Queen, Princess Diana, imagine some of you have heard of her, Royal Highness Princess Alice, and His Majesty the Sultan of Brunei. I worked closely with the staff of Buckingham Palace, that's the Queen's main residence, and that's a letter from the staff of Buckingham Palace saying that the Queen gave me permission to wear this medal that I was very honoured to receive from the Sultan of Brunei. And that's just a little clip. I'm on the end there saluting to say goodbye to His Majesty the Sultan. After leaving the Royal Air Force, I went to the University of Nottingham. I studied geography there and I got a first class with honours. I began a PhD in human geography at that time, but I didn't complete it as life happened and we stopped to have a break for family. We have two daughters who are 21 and 24, which is probably a similar age to some of you in the room. After my husband and I left the Royal Air Force, we set up our own technology company called Muirtex. We were small, but we were nationally successful. I think in university situation it's similar. There's a scheme called match funding. In the UK, the government provides match funding for cutting-edge research. So twice we got funding, which meant we could have double the amount of money and double the research impact. And we were active in sectors of defence, robotics, and autonomous systems. Our core capabilities are here: autonomous systems, HMI, unmanned air vehicles. My husband was aircraft dynamics and principally control engineering. We used, this was one of our bids to the government for using Google Glass for training. In this case, it was Google Glass, but we were opting for smart glasses, Vuzix, Epson. This was another project we did in the food sector. It doesn't actually say on that slide, but it was with Lincoln University. And a combination of robotics and automation, they argue, would be the future for food manufacturing. In the UK, there's a lot of automation in food manufacture, not quite as much as Germany, but we're catching up. This food packaging production line is obviously just straightforward automation, and a lot of the workforce were reduced from 35 down to just 5 workers. But what that does do is put a huge pressure on the production line to have things ready. And the production line manager, you can see, perhaps just make out there, is wearing Google Glass, I think. And what we were trying to do was upskill the key workers at the point of need to provide information that they would use in the food factories. On this slide, it's forklift truck driver. These food warehouses and factories are huge, massive, and an awful lot of stuff is moved via forklift truck. It's combined into food menus or ready meals. If the wrong ingredient is placed in, it has an impact to the company of perhaps millions of pounds as they have to do a food recall. So something as simple as having QR code recognition on the glasses would prevent the wrong item being picked up and mixed into the food. Another idea we had was for collaborative work with Rolls-Royce Engines and Coventry University. It's a small picture there, but that's a piece of an aircraft engine. Aircraft jet engines are actually enormous, perhaps the height of this room, and the technicians often have to climb up ladders to provide the interface between the aircraft moving parts, the wings and the ailerons. There's a control engineering system, and the wiring for that is huge, massive amounts of wiring. So often the technicians would be at the top of the ladder and have to try and remember what connection they were making. They would have to travel back down and then scroll on a screen to see what they were doing. By using smart glasses, they could have the information at point of need. This picture, I think, is Amazon or FedEx, but it's showing another project, a successful project we had for robotics and autonomous systems, combining smart glasses, smart glove, and drone. And this is a picture of me with the smart glove. We're using gesture control to control the drone. And just a small picture of the drone in the center, and using the gestures to control the drone to just go to the tower and collect some simple QR code information. And that was improving the complexity that the drone pilot can often experience when the camera has front-person view. When the drone returns to you, you have to reverse the control maneuvers. But by having the information applied to glass, it's a lot more intuitive. For a change, we moved to Cardiff, and I started at Cardiff Met Technologies, School of Technologies. The course is offered, it's probably too hard to read, but advanced computer science, advanced computer security, and data science, several others. Although I had no computer science experience and zero programming experience, I really was interested in data science. So I took the MSc in data science. My first module was with Dr. Chu. It was social media analytics, and I was just inspired to continue. My next module was programming, and again, as I said, no experience. So that was quite a slog to begin that. Took a Kaggle data set and then eventually programmed 3 machine learning models. And that was exciting and really enjoyable. For me, the next step is this large building. That's where the Cardiff Met students graduate. And just later this month, in a few days, I'll be inside getting my qualification. Quite exciting. And then we will have a holiday in Yorkshire. So in conclusion, I hope that my commercial, administrative, technology and data science background is a skill set that I can bring to the Eureka Robotics Centre. And if you do find yourself visiting Cardiff Met School of Technologies, a very warm welcome will await you. Thank you.
What a lovely presentation by Caroline. Thank you so much for sharing your experience. It's a very unique experience. I think it's not something that we are used to, especially for ladies. You were from a workforce, from the industry, and then you come in doing your PhD. Life happens, but you didn't give up. You rejoined the academics, and now you're one of the person I look up most. Thank you for your experience. I would like to present the last talk from today. Dr. Devi Fitriana from Mercu Buana. Sorry, you formerly from Mercu Buana, and now she is with Venus University, Indonesia. So she has a slightly different talk. So I think you're not a roboticist, right? But she does a lot of machine learning, and she's part of the Pi for Women program, part of the member, and her talk would be on machine learning implementation, focusing on blue economy. Please welcome Dr. Devi.
Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. I would like to say thank you first to the Dean of the Faculty of Computer Science and Information Technology, Professor Lu. Thank you very much for having me here, and also Dr. Zati and the committee for organizing this wonderful event. Thank you very much. Today I'm going to talk about machine learning implementation here. About spatio-temporal data exploration for blue economy. This is actually one of my research in my PhD. Okay. I went to Universitas Indonesia for my master and PhD, and to Bina Nusantara University for my bachelor degree. Okay. So this is the outline for my talks today. So it's nothing about robotics. But I'm sure that it can inspire you about this marine technology. So we are going to talk about blue economy, IT utilization in marine sector, data exploration, paper that has been published, the next studies, the opportunities, and also the conclusion. Well, actually, the blue economy is actually the concept of sustainable economic development centered on the sea, while still paying attention to the sustainability of the marine ecosystem itself. Actually, this term is introduced by our previous president, Bambang Susilo Yudhoyono, in 2012, because Indonesia, just the same, with Malaysia, that we have very abundant marine resources. So Indonesia is the second longest coastal long maritime country. We are the second, and then we also need the technology, accompany the fishing technology, of course, whether it's the ships and then the GPS and also the VMS. VMS is actually a vessel monitoring system. It is a kind of tools, devices that is installed in the ships, to know whether the ship's going anywhere. Okay. And then Indonesia also become one of the leading export commodities, especially for tuna, and also shrimp, squid, crabs, etc. Okay, so but we actually face some difficulties. For example, like the fishing effort and also the selling is not optimal yet. Yeah, so from these problems, we try to, to cope, and then we try to elaborate what is actually the technology needed for this one. So there I propose the IT utilization in marine sector, for example, like the fishing data. This data is actually contains information about the catch area, spatial data, and when it was caught, also the temporal data, as well as the number of catches. Yeah, so we don't think about the kilograms, not the measurement, but the number, because tuna comes in very big size. Yeah, so one tuna captured means is more than two lah, more than two if you want to have a good potential area, considered good potential area. And then I also will use the oceanographic parameters here, like the physical, biological, and chemical oceanography, and also the appropriate type of model and algorithm. This is very urgent because of the nature of this, the data. Yeah. Okay. So the first one, we are going to talk about the daily catch data for the exploration. So here we use low granularity. It is the daily fish catch data. It is taken from the vessel, the fishing logbook. Yeah. Well, usually for tuna, they have specific ships. Yeah, long line tuna vessel. So the spatial information also obtained. Yeah. So every stop, it is the vessel. Yeah, to determine the fishing area, and then the catch point is recorded with it 4 kilometer times 4 kilometers. So it is considered a grid, yeah, in the sea. And then from the same point, or when it is when the boat first lowers its fishing line. So the tools is also different with the usual one. Tuna is fishing, so you just fish, not catch using the net. Yeah, that's a kind of different method. And then also the temporal information. This is it means registration start from 0, yeah, to 23:59 every day. Now this is the type of fish. Sometimes when we fish in the specific area, not only tuna. Sometimes we also catch like marlin, yeah, like skipjack, also considered tuna, but different species, yeah. Okay, so this fish catch I obtained from PT Perikanan Nusantara that is located in Bali. So can you imagine, every time I got the data, it looks like I have a long vacation because I have to go to Bali, yeah. But actually I am working there. So this is the PT Perikanan Nusantara actually operating near the south of Bali until the Iceland. Yeah, so I also ever come with them fishing for 2 weeks. Actually, the vessel is due to 1 month, but I cannot do it because it was so hot, and I begged them to take me to the ground. Yeah, only for 2 weeks. Only for 2 weeks. So after the data of the fishing, then we go to the oceanographic data. This is also very important to know the oceanographic data. We have biological, physical, and also chemistry. The oceanographic parameter affects the life and the growth of marine organism and their association with their habitat. It is very important. Why? Because tuna eats fish, small fish. But small fish is not will be there if it is not what do you call it? Fertilized, because of the plankton, right? So it is a kind of chain. Okay, so we just cannot think that it is tuna will be there if only just seeing the oceanographic, yeah. And then there are 3 types, as I told you earlier: the physical, the temperature, the brightness waves, the tides, the currents, and also the biological. This is the chlorophyll A, the phytoplankton, yeah, and also the chemical. Yeah, talking about the salinity and the pH of the water. Now, this data can be captured with the satellite. Now, I use MODIS Aqua. Yeah, MODIS Aqua. It is a satellite that's cover 3 parts. Okay, and then it takes 2 photos each day, and then around the world. around the world. Can you imagine? 2 photos, 30 days, 50 images, and then one year, 730 images, and then it's only for one feature analysis. So if it is only processing using only the geographic information system, that will be very, yeah, can imagine about that. Yeah. So we try to use this data, and then there is also an application called CDAS. Yeah, actually it is NASA, from NASA. I got this from Ocean Color. So I use the application just to derive the text, the actual data from the image. So I got the text. For example, like longitude, latitude, and then the value of the chlorophyll and also the sea temperature, the sea surface temperature. Okay. Now this is the example of the data. This is the raw data. And then I used to convert the radians. Yeah, this is the level 1. We have to, what do you call it? Doing some tuning of the image. And then we do some atmospheric corrections here. Sometimes the biggest enemy of these, remote sensing is cloud, right? So I have to do some cloud discrimination, yeah. And then we also have this chlorophyll concentration, again, using the in-water algorithms. Actually, for sea, there is different, yeah. We have 2 kinds of algorithm that processing the chlorophyll. So we have beach, yeah, from beach, and then we have blue sea, yeah, deep blue sea. And then we do some geometrical corrections, and then there is weekly, monthly, seasonally map, yeah, for the sea surface temperature or the chlorophyll A value. Okay, so this all I got from the image that is downloaded, processed from the Ocean Color satellite. Yeah, one of them is Modis Aqua. Actually, there is Modis Terra, but Modis Terra is covering the land only. So this is the 8-day chlorophyll value that I managed to derive. Yeah, as you can see here, the blue one. Yeah, the blue one, and then sorry, this one considered the chlorophyll is very rich. Yeah, and the black one is the land. This is the area of Java. Yeah, and Bali is here. Okay, as you can see here, this is the blue sea. Yeah, and it is very rich, yeah, in chlorophyll. Now this is the concentration, yeah, from each month. I got this, yeah, with different concentration, of course. Now this is the composite value, yeah, for that I got each for 8 days, yeah, 8 days measurement. Now this is what I told you earlier. We are using CDAS, okay, to deliver, to generate the text from the image. Okay, so can you imagine one image only? And then I use this. For specific region, this is the south to Bali until Iceland. It took me about 8 months lah, yeah, 8 months. 8 months to process this into a textual data. Now this is the in situ measurement. So I do that because just want to make sure whether my data that is derived from the satellite is okay. Yeah. So we do some measurement using the spectroradiometer and also some water sampling. So this process only took me about 2 days. Yeah. So we go on the spot, yeah, using the longitude and the latitude, and then we check all using this spectroradiometer and the water sampling. That's it. We got the value. Now, after we got the oceanography, then we try to explore the model. Yeah. So actually, there are 4 that I use to play with. I'm not saying research. Yeah, I play with. The first one is the data integration. Of course, we have to combine all the data needed. We have the catch data, we have the oceanographic, so many sources. And then we also have what do we call it, from expert judgment, whether it is potential or not potential. That will be our label, yeah, for the class level. And then after that, we also play with the feature selection, which area that really identified as a potential fishing zone based on the characteristic of the oceanography. And then later on, we try to do some clustering, yeah, classification and prediction. Well, actually, my work is more to the unsupervised learning, to the clustering, because not even in on Earth, yeah. This is what my professor said. In sea, we never know what happened in the sea. It's very, yeah. Even on the ground, you don't have any clue about it. Now you talk about the sea, so you just do some clustering then, Devi. Don't do classification. Okay, so I think that's a very wise things, yeah. So I don't have the label yet. I don't have the class yet. So okay, so clustering will be very suitable for my research. But again, later on, after I do some clustering, I have this called ground truth, right? So I have already got this. Okay, this one is potential. This one is not. So that is going to be my label. So I level up the research and becomes the predictions, and later on, yeah. So this is my data. So as you can see here, this is the spatial pattern, right? Yeah, okay, so this is the longitude, the latitude, and then for each window, so we have temporal pattern. So actually, I haven't tried this research yet. It's about trajectory, but later maybe. Yeah, so actually, this going to be a trajectory, right? But unfortunately, my PhD stopped at 4 years. Otherwise, I don't graduate to become a doctor, yeah. So I just finished there. Okay, so based on this spatial pattern and temporal pattern, so I try to see that it is actually a grid. Okay, in bahasa we call it wilayah perikanan, penangkapan perikanan, or it is a code of area that we catch the fish. This PT Perikanan Nusantara has already a WPP, or what we call it fishing grids. Yeah, fishing grids. So based on this nature of the data, I try to do some definition here. Yeah, talking about the data, talking about the grid. The first definition. So just to simple it, we have neighbors. We have neighbors. Actually, I have this intuition by using the DB scan. All of you have already familiar with DB scan, yeah? It is a kind of clustering related with the spatial data. So mine is different. Not only the spatial, but also the temporal. We have to consider that. Yeah, and those three different dimension as well. Yeah. So I see this. I have this definition. One is about neighbors. Okay. So since it is three-dimensional data, so I call it cube. Okay, cube. Okay. So the neighbors, the cube will consider a neighbors, and if only. Oh, sorry, I haven't. Sorry. So if the cube is next to the other cube, that is considered, yeah, considered from the Q, there is I1, I2, and I3, where I and G is actually the interval of the cube. So I used to divide, yeah, the dimensional space of the data, and the division is based on the interval. So I take this interval. Now that's the neighbor, and then the second one, immediate neighbors. Yeah, the immediate neighbors, it means that, okay, I think it's better if you see the picture, yeah, because all of you are already talking about, it seems like you telling me that you want to have a lunch early. I can tell from your eyes. Okay, so this is what we call the cube, yeah, and this is what we call immediate neighbors, yeah. So the idea is very simple. The immediate neighbors from the cube is actually the one side that is, yeah, what is it? Close, yeah, close, okay, for this one. And this is what we call the it neighbor. So if you have this as your neighbors, so this is the I2 is actually called the it neighbor. So I try to scale up the grid, scale up the cubes, yeah. And then this one is actually the next it, okay. This is the first it and the second one, yeah, the second neighbor. So it is the corner of the cube, okay. And then by definition 4, we can see it that we call it the point, okay. Why? Because this fishing has a specific longitude and latitude. That's a spatial information. So it is the point. So if there is the point in that cube, it means that we have the neighbors, we have this is the immediate neighbors, and this is the first neighbors, and this is the second neighbors. Yeah, so it goes like that. Okay. Now, I developed the spatio-temporal grid. So the grid actually based on the spatio and the temporal, yeah, but it is not very successful. But I managed to do some partitioning and also calculating the R. R is actually the interval, yeah, also the radius for the data. And I calculate the density, and then trying to compute the density compensation, because the density compensation is very important, whether it is dense or not, okay. And then in one cube, is there many points, yeah. And also do the clustering and remove some noise, and it becomes a convergence cluster. Now, what we do is the adaptation here with the partitioning and the calculating R. This is the result using the ST grid and compared with the DB scan. But the DB scan here using the minimum points 5 and the epsilon 0.5. Now, as you can see here, this is the potential one. But it's still in the form of grid, yeah. As you can see here, yeah, there is grid. Okay, so the red one is considered fishing area, but the potential one is only here. Yeah, this is the prediction. So I come up with the prediction there. Okay, this is the monthly, weekly, and daily data. This is the data, actually. And then this is the result of my prediction using the ST grid algorithm. So I have this monthly, yeah. And people will say, why do we need monthly, weekly, and daily? Because Alhamdulillah, last year I got this grant from the Ministry of Fishery and Marine and Fishery Affairs of Republic of Indonesia. I have this kind of, like mapping for fishing. And then we do this study case in 2 places, in Semarang Harbor and in Yogyakarta Harbor. So fishermen who wants to go fishing, they got this kind of, like map where they should go, and then, the prediction about the fuels. Also, I have, provide them with that kind of information. Now, this is my published paper from 2020 and 12 until 2021. And this one, a collaboration paper with one of Malaysian person also, Professor Fang Ning Tan. He is in Michigan State University now, and he was my supervisor when I visited MSU. And he said, well, Devi, it took you a long time until 2021. Well, actually, I graduated from 2015. Yeah, it took me 6 years, yeah, to be able to publish this paper with him. But yeah, he always supporting me. Yeah, thanks God. Okay, so as you can see here, my published paper is all about marines, technology, clustering, etc. Yeah, and this is my challenge, my next study. So I'm going to develop also the unsupervised learning. This one is actually, the paper is already in the 3rd round. I don't know how many rounds will go. It's about improving the methodology in algorithms of this unsupervised learning, still using the grids, yeah, and also the smart system. Maybe this one I can collaborate with Ashin, yeah, talking about the smart system. Maybe we can have tools like in Japan, yeah, they can use this in the vessel, and then they can already allocate where the potential and non-potential area. Okay, okay. And then the last one is the business model. I invite friends or colleagues that from information system maybe can help me with this one, with this business model, because in Indonesia we still don't have that kind of business model, especially in fisheries industry. Okay, that's the conclusion. So for me, yeah, this is for me, understanding and mastering the data exploration is as important as understanding and mastering the implementation of machine learning models. Why? Because as a data scientist, first thing you have to know your data, the characteristic of your data, because you cannot do anything, yeah, or if you're a doctor, you have to know the symptom, you have to know the behavior of the data. That's why you can do the next step, yeah. And then this is also comes from the understanding of the problem domain. Can you imagine? I have to go to Bogor. It is in West Java. Yeah, it is West Java. It took me 4 hours ride using car just to understand about the remote sensing. Yeah, from IPB, Institute Pertanian Bogor, or Bogor Agriculture University. And it happens for almost a year, just to understand about the remote sensing technology. And then, yeah, thanks God, the professor is very supportive also, and he considered me as his child. Thanks God. So the proposed framework can also be implemented. The one that I got from my publication, the proposed framework, it is also can be implemented in other domains. Yeah, like for example, in forest fire, I also got these grants from the Ministry of Education and Culture in 2 years in a row, and then it's already published the paper, and also being what do you call it? Intellectual property rights. We have that. And the last one, for me, information technology with its various fields can provide more benefit if it's collaborate with domains from other fields of science. For example, like in marine resources exploration, and then now in Indonesia, we are hyped, yeah, for the disaster mitigation, smart farming, because our country is actually needs to develop more than in smart farming, yeah, and healthcare, etc. Okay, I think that's all. Life isn't a matter of milestone for me, but of moments, just like what Rose Kennedy said. Thank you very much for your kind attention.
Thank you so much, Dr. Devi. I think the most interesting part for me from your research is the chlorophyll A prediction, because I do a bit on that for my robot. Because I was trying to do a bit more applied robotics, and one of it is application of robotics for environmental sustainability. So a bit of the chlorophyll A prediction is part of my work. Other than that, ocean, I haven't touched it. So I only stick to, because UM only has a lake. So my robot can only do the lake at the moment. Ocean, not yet. Okay, look forward to collaborating with you, especially on the second agenda that you have, the smart system. Yeah, thank you. Right, so moving on, our final task for today is to token of appreciation. So let me invite again the speakers, Dr. Ishin, please come forward. Dr. Barry, please come forward. Sia, please come forward. And Dr. Devi, please come forward. Can I get the So we are going to arrange a little bit on the stage, but please, the speakers can come upstairs. And I would like to invite first, I think, Associate Professor Dr. Siti Hafizah, because the Institute of Advanced Studies has some gift for the speakers. So how should we arrange? So Dr. Maybe apa tak sure? Oops, okay. So Wadi, ready? All right, so the first one is for Dr. Yishin. This is from Institute of Advanced Studies. Yeah, okay. Okay, Dr. Barry, come forward. Yeah. Yeah. We won't do one by one. We'll just call the group and you give to all. Yeah. Okay. So please, Dr. Barry. Sia, can I have you, Sia? Yeah. Yes. Okay. So next is Dr. Sia from IAS. Who can come? And last but not least, Dr. Devi. Okay. I actually would like to remain the speakers on the stage because we have so many gifts for you. So I would like for you guys to remain on stage. And then next, I would like to call Dean of Faculty of Computer Science, IT, Prof. Lu, to give his token of appreciation from our side. Please remain on the stage. Please. It will just take a group photo. Yeah, please remain on the stage. You can remain as well. Yeah. Okay, so we'll just do a group one. So Prof. Lu can just distribute. Okay. You follow, Prof. You follow, Prof. Follow, Prof. Okay. Okay. Yeah. So, because we have so many gifts, so we'll do a faster one. Right. The speakers can come forward because it will be a group photo. So come forward, and Prof. can distribute. We don't have to do one by one photo because yeah, we don't have to do one by one photo. Okay. We'll do a group photo. We don't have to do one by one. Yeah. Thank you. Right. Yes. Yes. That'd be great. And I think, interestingly, Dr. Devi has something for us, right? So Dr. Devi would like to give a token of appreciation to Cardiff University. Dr. Devi, can you come here? Yeah. Can you just pass? Right. So from Dr. Devi to Cardiff, and okay. Wow. Okay. Thank you. Right. And Dr. Devi also have a token of appreciation for Universiti Malaya. So the recipient would be Prof. Lu. Prof. will receive it for us. Okay. You give to Prof. Lu. Yes. Yes. So we can bring it up and for the photo. Yes. Dr. Devi also have token appreciation for UITM. Right. So please come forward, Associate Professor Dr. Rosita. Yes. Okay. And then we would like to have arranged for a group photo among the dignitaries. And after that, I would like to call everyone to join us on the stage for a big photo together. Right, so can I have everyone to the stage? Don't know how we're going to arrange this, but I'm sure. Oh yeah, from this side. Okay, then I'll welcome all of you to sit. All right? Huh? Oh, okay. Dah ambil kan tadi? Okay, okay. So I'll join. Yeah, I'll join. Okay, so that wraps up the research side of the event. And for the students, I know you've met students from UK, have met students from Malaysia, and I think we have a robot demo on the cubes. So while waiting for lunch to serve, maybe you can bring the students over to the other side for robot demo. Anyone interested to see robot in action can move to the cubes now for the presentation. Thank you.